Hey guys, it's part 2 of building a data wheelbase. In the previous video, we completed the mechanical side, the encoder, and also started working on the back panel. So in this one, we will complete the entire wheelbase, including circuit diagrams, connections, and uploading the firmware to the control, and also setting up the FFB software in the PC. But first, I need to address an issue that I was facing, which is the encoder. The encoder I got was the MT6835 magnetic encoder. There are different versions available, but the only difference between them is the PPR. So PPR is pulse per revolution, and I got the one with the highest PPR, which is 16384. And while setting up the FFB setup, I had to enter the encoder CPR. So CPR is 4 times the PPR multiplied by whatever reduction ratio you have, and in my case the ratio was 4. So the CPR becomes 4 times 16384 multiplied by 4, which is 262144. But the issue here is it's a very big value. The maximum value that I can enter into the FFB setup is 65535. But thankfully our encoder is user programmable, so I can reprogram the PPR to a lower value like 2048. To do that, I connected the SPI pins of the encoder to my ESP32. But while reading the current PPR, it was 16383, which was 1 less than the actual value of 16384. So as the new PPR, I had to enter 1 less than 2048, which is 2047, to get the new PPR of 2048. Therefore, the CPR of our encoder is 4 times 2048 multiplied by 4, which is 32768. And with the current CPR, everything is running properly. And also shout out to JLC CNC for reaching out to me, and they offered me access to their CNC services, which is something I could use right now. Because now the encoder shaft is the weakest part in my design. The 3D printer parts on the shaft is good for testing, but not great for long-term use. So for the next upgrade, I'm planning to get the entire shaft CNC machined with the help of JLC CNC. So JLC CNC is a trusted CNC machining partner, offering fast, affordable and high precision custom parts for makers, engineers and businesses alike. Whether you are prototyping or scaling up, JLC CNC can help you bring your ideas in life just like how you designed them. They offer competitive pricing whether you are ordering a single prototype or a batch, and there are no additional setup fees. Their process includes multiple quality checks, and they support multi-axis machining and a variety of materials like aluminum, brass and stainless steel. If you want to try them out, you can get a $70 coupon to start your CNC machining for just $1 at JLC CNC. Check out the link in the description. So this is the wiring diagram. The RJ45 female connectors are not included in this diagram since I am not using them right now. They are just for future proofing. The relay here is used to cut the power from the power supply, and it is wired in normally closed state at low trigger mode. So when the emergency stop button is pressed, the signal pin of the relay will be grounded, causing the relay to open circuit, therefore cutting the power. For setting up the controller, first we need to create a new folder. I already created one in the C drive and named it FFB. Now we need to go to the FFB's website, click downloads and then wheels. In here we have the full software files and also the patch file. First we need to download the full version, which is RC24144. After downloading it, open the zip file and extract all the contents to a previously created folder. After the extraction, we can see here the new files in the FFB's folder. Now, in order to upload the firmware to the controller, we need to download the STM32Cube programmer. So let's go to its download page. Select the latest version. Now we need to enter our name and email ID so they can send us the download link. It might take some time to get the link, but since I have already downloaded the file, let's go and install it. After opening the STM32Cube programmer, we need to select the USB option. And in order for our controller to show up under the USB, it needs to be in DFU mode. To put our board in DFU mode, first make sure our board is connected to the USB and powered. Then there are two ways to do it. First one is turn the power off, then press and hold the boot button, then turn the power on and wait till the board powers up. Now release the boot button. This will put the board in DFU mode. And the second method is keep the power on, then press and hold the boot button and then press the reset button for 1 second and then release it. Then release the boot button too. Any of this method will work, and when the board gets into DFU mode, the controller will show up under the USB option. Before uploading the firmware, it is a good practice to erase the board memory when we are using it for the first time. Now click the plus icon and select open file, and then select the FFB's hex file that shows up and then press download. Now we have to upload the patch file. For that, again go to the FFB's website, click on downloads, then wheels. From here we have already downloaded the full version. Now click on the patch version which says RC2415 patch. After downloading it, open the zip folder and extract all the contents to the same FFB's folder. Here we can see the files have changed in the FFB folder. Now open the STM32Cube programmer again. Close the previously opened file. Then click on the open file, and now hex file for the patch is also showing up here. So select the new hex file for the patch and click download. And since all the uploading is over, we can click the disconnect button and close the program. Now if you go to the FFBs folder and choose the FFBs application ending with .5, the setup will open up, but nothing is showing in the setup. This is because we are still in DFU mode. To get out of DFU mode, we just need to press the reset button or turn the power off and then on again. And if we try to open it again, the setup will show up and it's working. In the effect tab, the range of motion of the wheel is set to about 900 degrees. You can change that to whatever value you need. And in the periphery tab, let's enable the reset center button. It's for the button connected to the Z pin that recenters the wheel when pressed for 1 second. And in the controller tab, invert joystick output is enabled when you rotate the wheel in one direction, but in the game the wheel goes the other way. And the invert force output is enabled when the feedback force is pulling the wheel in the opposite direction than it is supposed to. For the CPR, I am entering my Encoder CPR, which is 32768. And the pole pair is half of the total number of magnets that is in your motor. Normally the hub motors have 30 magnets, so half of that is 15. So I'm going to keep that as 15. Now the proportional integral gain, I'm going to leave it as the default values. You can tune it later if you need. And for the power limit, it's the maximum power that at which the motor performs. And I'm going to put that to about 30% for now. And the braking resistor limit decides how much braking force does the motor provides. And before saving the settings, let's enable the forces and save and reboot. One of the common issues that we might face during this process is that the board being not able to connect in the STM32Cube programmer. Here, even though you made the board go in DFU mode, the programmer will only recognize the board if you are using WinUSB as the device driver. So it's a driver issue here. And if we go to the device and driver section, we can see that the STM32 bootloader is showing up. That means our board is in fact in DFU mode right now. And to check if it's using the proper drivers, we need another program called Sadiq. And if we choose the STM32 bootloader as device in Sadiq, it will show the current driver used, and if it's not WinUSB, we can easily change that by choosing WinUSB on the right side and clicking the upgrade driver button. I added a cooling fan for the motor at the bottom and used some 3M double-sided tape to put it there just to see how it performs. The fan do help, but for longer sessions it's not the best choice, and I do need to get some more cooling. I probably should get some holes drilled in the motor or even get a bigger motor in the future. For the emergency stop button, I again accidentally ordered the wrong one. I got the normally closed one instead of a normally open one, and I should get the proper one later. But for now, I got a normally open contact element from a different brand which didn't fit this kill switch, so I had to hack that into it, and that's why it's wrapped up in tape right now.